Well, hey, I'm Alex. I'm one of the co-founders and CEO at Snorkel AI. I'm also on faculty at University of Washington in the CS department, and I'm incredibly privileged to be talking with Ananya today. Ananya, you want to give a quick intro?
Yeah, hi. I'm a fifth-year PhD student at Stanford, and I work with Percy Liang and Tengyu Ma on understanding foundation models and robustness to distribution shifts.
Well, I'm super excited to speak today. So, you have a ton of really exciting work that you've been putting out there in that domain. Pun, I guess, subconsciously intended, given what we're about to talk about. But I'm going to focus on maybe just one paper today. So this is Connect, Not Collapse, explaining contrastive learning for unsupervised domain adaptation. Mm-hmm. So maybe I'll kick it off by just asking if you could, share a little bit about the paper, the kind of motivation for studying this problem in the context, especially as it connects to foundation models, to different data domains and the way that data plays a role in that, and then a little bit about what you did and what the results were, and we can go from there. Sound good?
Yeah, sounds great. So I think one aspect of these foundation models like BERT, GPT-3 or SimClear that I found very cool is how robust they are. So if you take a foundation model, like say take SimClear or CLIP, and you fine tune these models on data from one domain, like data from North America, and you test them on other domains where you've only seen unlabeled data. So you test them on new countries, it does remarkably well. And it leads to state-of-the-art results on a lot of these real-world robustness data sets in satellite data, wildlife conservation. And so I was really interested in understanding, how does this happen? Like, how does it lead to such good robustness? And does the data you pre-train on, does that play a big role? And so that's the main question we're studying in this paper. And what we found, we kind of studied this in a controlled setting where you have unlabeled data from a few domains and labeled data from one domain. You pre-train on all the unlabeled data. So you can imagine you pre-train on satellite data around the world, and then you fine-tune on data from North America from one domain, and then you test it everywhere in the world where labels might be scarce. And so we kind of found that this works really well, first off. And second, it works very differently from conventional intuitions in the domain adaptation literature. So it kind of doesn't merge the features or representations learned from different countries or domains. So that doesn't happen. But instead, if the data satisfies some good properties, instead it kind of disentangles the information from different domains and the class information you care about. Yeah.
That's super interesting. Okay, maybe I'll start with a really basic one, which is, what does the work kind of, and what did this project all kind of, illuminate in terms of where this works and where it falls short? In other words, if you're just looking at it from a practitioner's lens and saying, okay, I have a model that's pre-trained on all of the sub distributions that I might care of in an unsupervised or self-supervised way, and I want to, and I want to try this kind of out of domain, zero-shot generalization. Where can I expect it to work versus where should I expect that I'm actually going to have to go and label data on the new sub distribution to get it to work? Like,
that's a great point. So yeah, that's a great question. So I think the highest level point is, if you've seen, you need unlabeled data from the domain you care about. So that's the first kind of thing. Sure. So if you don't have any unlabeled data, if the data you're testing on is just, I don't know, Mars, and you don't have any data from that, then you can't do it. The second thing we look at is basically, we look at this method called contrastive learning. And what it does is the key player there is augmentations. So you take augmentations of the same image, so kind of like tiny crops of the same image, and you map them to similar representations, and augmentations of different images, you push them apart. And basically these augmentations, you can view them as connecting different domains. So you can imagine that there are images in the US and images in Asia. Like if you apply augmentations, they could look similar. And so the question, the key property you need is, you need some connectivity between these domains that are induced by the augmentation. So basically, if you have data from North America, and no matter how you augment it, it can never look anything like data from Asia, then you're not going to expect this method to work well. But if there is some connectivity, then you can expect it to work well. And there's some slightly more technical details, but that's the gist of it.
Yeah, I'll make a brief shameless plug that Ananya is going to be speaking at the foundation model meets DataCentric AI Summit that we have virtual summit on January 17th. If you want to get into the details, and there are absolutely details that really treat this in a really exciting and formal way. Well, I don't know what you're going to talk about. I'm sure you're going to get into at least a little bit more. So please, check it out then. I'll keep it high level for now. But maybe so one implication, just practically speaking, is just to echo back what you said, is that this is really these kinds of approaches or this kind of framing is applicable when you have access to all the unlabeled data, but you're bottlenecked on the labeling of the data, right? So it's it's not like you're going from from Earth to Mars, or from Reddit to complex medical documents. It's more like, okay, you have both Reddit and PubMed in your unsupervised training set, but you only had again, maybe we could talk about whether that's too distinct per your linkage criteria, but the bottleneck is really like, you only have labeling for kind of one of those subdomains. So that's kind of, again, this theme of many settings have plentiful access to unlabeled data, and I think we're going to see much more of that as the architecture, especially in foundation model world, as a lot of this opens up and we find ways to to build smaller ones and build them on-prem and build them on more kind of specific specialized data sets. You're going to see probably more settings where you have access to the unlabeled data, and you're just blocked on the labeling of the data. Is that in line kind of what
That's exactly right. Yeah, we're kind of envisioning that you have tons and tons of unlabeled data. It's like satellite data from around the world. They keep going around collecting data, or like cameras around the world collecting wildlife conservation data, or data from all across the internet. So yeah, exactly.
And you have access to then train foundation models or on this data. So you'll have that the unsupervised data represented in the training set, but you won't have necessarily that label data for the specific target task you're trying to accomplish.
Exactly.
So that seems super relevant and definitely mirrors with what at least we're seeing from our perspective. And then the second element is super interesting. I know we're running out of time, or we got like a couple of minutes left, but this idea of kind of being able to link from one subdomain to another versus augmentations. We did a little work on this back in 2017 around kind of like we thought about this idea of transformation functions for data augmentation. We weren't thinking about it for domain adaptation, just for optimizing data augmentation. Can we figure out automatically the right amount of degrees to rotate the digits to improve the performance, or the right kind of like crops to apply? And a lot of what this came down to was it was automated in terms of applying and tuning the optimizations, but it did require someone to kind of engineer the types of, we call them transformation functions, but the types of kind of core augmentations, kind of like you said, what types of building blocks, what types of augmentations, crops, rotations, shears, dictionary replacements, whatever it might be, are going to be able to get you from one domain to the other. So it's a little bit of a leading question, but just in your experience carrying out this research, how much does this, do you think, require or rely on kind of engineering of these augmentations to kind of, in your language, connect these spaces, versus how much of it can be done just out of the box?
Yeah. First off, thanks for sharing your work. That sounds really great. And secondly, so we mostly looked at manual in this paper. We mostly looked at like manually choosing these augmentations, but currently we're working on automatically kind of using these criteria to optimize the augmentations you choose. So I think that's a great line for future work.
Very cool. Very cool. Well, I'm sure you'll talk about that and much more in the summit talk coming up on Jan 17. But I guess I'll wrap up now. Ananya, thank you so much for joining us and for sharing more on your awesome work.
Yeah, thank you so much for having me, Alex.